And welcome back. As we go ahead and continue our journey into Java, let's go ahead and this time discuss a new concept which we haven't discussed, but we might have inadvertently stumbled across, which is that of copy constructors. So let's first talk about what the copy constructor is. Well, a copy constructor is a constructor with a single argument of the same type as a class. A copy constructor should therefore create an object that is a separate, independent object, but with the instant variable set so that it's an exact copy of the argument object. So for example, if we have a, let's say, toy class, and I wanted to make a copy of that, I would plug in as the parameter type, instead of like a string or int or something like that, it would be a toy class. So for this, we're going to start by taking a look at the date class, which we've used previously. In the date class, there is a copy constructor, and what it does, it creates a new object of the class date. This happens automatically and is actually not shown in the code for that copy constructor. The code for the copy constructor then is going to go on to set the instance variables to the values equal to those of its one parameter, a date. But the new date created is a separate object, even though it represents the same date. So in memory, if you were to look, there'd be two different slots that would be occupying it, even though the values of the variables that would be associated with it would be the same. So with copy constructors, let's look at this with an example to really kind of help hone this in. So let's say we have these two dates. We have date 1, which is January 1st, 2015, and date 2, which is a new date, date 1. Now, after this code is executed, both date 1 and date 2 are going to represent the date January 1st, 2015, but they are two different objects. If we change one of these objects, it will not change the other. So if I do date2.setDate, July 4th, 1776, and then do a system out of print line, we're going to get the output of January 1st, 2015. All right, because even though we changed date 2, it was not at all related to date 1. We simply had originally copied that value over. So again, when we change date 2, it does not change date 1. However, things don't always one-to-one correlate. Let's look at the person class here to see how things might be different. So let's say we want our object to be an independent copy of the original. That is our goal. We don't want them to be intertwined so that if we change one, it affects the other. In the person class, though, the way it's set up, this is not going to work as well. All right, if we use the following method here. So here we have public person, person original. We say this is an unsafe copy. We say if original is not null, we're going to, if it's equal to null, print out an error. Otherwise, we're going to say name is equal to original name, born is equal to original.born, died equals original.died. And you might be wondering, why do we have these flags here? Why is this saying this is unsafe? Why are these not good here? Well, let's dive a little bit more into that to see why. And it looks innocent, right? Everything here says this should be fine. Like, I don't see anything that could potentially cause issues, but there actually are some deeper issues here which can have some serious ramifications. So let's start with the top there with the unsafe code. Assume we use that unsafe version of copy. The not good segments in our code simply are referencing the original.born, original.died to the corresponding arguments of the object being created by that constructor. So the object being created, therefore, is actually not an independent copy of the original object because, again, it's referencing those things. It's not making a copy of them. It's referencing those original parameters. So if we look at this code, person original equals new personality address, new date, April 1st, 1984, null, person copy equals new person original, copy.set birth 1800, system on print line original. The output would be now addressed, April 1st, 1800. And you might be looking at this like, wait a minute here, we're printing out the original, but notice we changed the birth year of the copy. So why does this occur? Well, as we mentioned, when we change the birth year of the object copy, we also change the birth year in the object original. This is because we're using the unsafe version of the copy constructor. Both original.born and copy.born contain the same reference to the same date object. And this, again, all happens because we're using an unsafe version of the copy constructor. Fortunately, we can use a safer version of the copy constructor that would set the born instance variables as follows. So if I said born equals new date original.born, Now we are no longer tying ourselves to the unsafe copy, because what did we do here? Instead of just saying a reference, we're creating a new instance of a date object, which is another way of also saying, you could also say this.born equals new date of original.born. Both of these are fine. I probably would use this way again because, as long as you are not overlapping your variable names, it should be easy to kind of keep track of these. Now, the version that we just looked at, which we use here, when we take a look at that, the instance variable this.born is an independent date object that represents the same date as original.born. So if you change the date in the person object created by a copy constructor, you will not change that date in the original person object. Also note that if a class, such as person, has instance variables of a class type, such as the instance variables born and died, then to define a correct copy constructor for the class person, you must already have copy constructors for the class date as well for those instance variables. Now, the easiest way to ensure this for your class is to always include a copy constructor in every class you define. Now, do you need to? No, but if you plan to do any kind of copy maneuvers, you'll want those copy constructors. Now, there is something to kind of be aware of if you're using copy constructors, which is that of privacy leaks. So if we look at this accessor method, get birth date for the class person, public date, get birth date, return new date born. We gotta be careful here because we don't want to make the mistake of defining the accessor method as follows: public date, get birth date, return born. This is not good. All right, this is because we have what's known as a leaking accessor method here. Even though these two methods look very similar, notice one returns a new date object, the other one does not. So what does that mean with this leaking accessor method? Well, assume we use the unsafe version, which is the return born. All right, what does that do to us? Well, it becomes possible for a program that uses the class person to change that private instance variable born to any date whatsoever and bypass the checks in the constructor mutator methods of the class person. So if we look at this code, which might appear in a program that could use that class person, we have person citizen equals new person, Joe citizen, new date, January 1st, 1900, new date, January 1st, 1990, date name equals citizen dot get birth date, date name dot set date, April 1st, 3000. And you might be wondering, wait, 3000? Well, let's see what this actually causes to happen. Well, as we mentioned, we have a privacy leak here. The code here changes the date of birth so it's after the date of death. The citizen, therefore, is not born until after he or she has died, which, of course, is kind of problematic. This sort of situation is what we can refer to as a privacy leak because it allows a programmer to circumvent the private modifier before instance variable, such as born, and to change that instance variable to anything whatsoever. So, even though we might have like if-else statements in check to make sure those are working, this privacy leak allows you to bypass that. So if we had code such as the following, this would be technically legal. Citizen.born.set date, April 1st, 3000. Now, why this is, why this is happening? Well, first off, we have to understand this code that we're looking at is illegal because the private instance variable for born is private, right? You shouldn't be able to go in and directly modify it. However, with our unsafe versions of the code, and let's just say we assume we're using the unsafe version, the variable date name contains the same reference as citizen.born, and so the following is legal and equivalent to our illegal statement. Date name.set date, April 1st, 3000. Now this is technically legal, and it's equivalent to our illegal statement. This is all if we use the unsafe version of get birth date, which simply returns the reference in the private instance variable born. Fortunately, here we have a safe version of get birth date, which has this following return statement: return new date born, which we already saw. Again, creating that new instance of that class there. Now, this return statement does not return a reference in the private instance variable born. Instead, it's using a copy constructor to return a reference to a new object. That's why we have that new date. That is an exact copy of the object named born. If the copy is changed, that has no effect on the date whose reference is in the instance variable born. Therefore, we can avoid our privacy leak. Now, just like we have leaking accessor methods, we can have leaking mutator methods. Note that returning a reference is not the only possible source of privacy leaks. A privacy leak can also arise from incorrectly defined constructor or mutator method. So let's take a look at this method set birth date in class person, and we're reproducing it as follows. So public void set birth date, date new date, if consistent new date died, born equals new date, else system.println inconsistent dates, aborting, system exit 0. When we look at this code, you'll note that the instance variable born is set to a copy of the parameter new date. Suppose though, instead of using that new date, we simply use born equals new date. Well, if we use this code here we're looking at in a program, you might be already starting to suspect what is going to happen based upon our previous conversation. Where a person object is going to name an object of the class person. The following course would then change the year part of the date object named by the born instance variable of the object person object, and would do so without going through the checks of the mutator methods for person, which of course would be date name.setYear1000. Because date name contains the same reference as the private instance variable born of the object person object, changing the year part of the date name changes the part of the year part of the private instance variable born of person object. Not only does this bypass the consistency checks in the mutator method set birth date, but it is also a likely source of an inadvertent change to that born instance variable. If we define set birth date using other methods for the person class, you'll notice though that that problem does not occur. Now, one thing that we do need to talk about as kind of our last point here for copying is cloning. Java documentation states that to use a method named clone instead of using a copy constructor. And there are situations where the copy constructor will not work as desired, and you actually need to use the clone method. However, for us to really have a good handle on the clone method, we need a little bit more background information. So at this time, we're not going to delve into the clone method. And despite what the Java documentation might say, many programs prefer to use copy constructors. In fact, for what we're going to be doing, a copy constructor right now will be a perfectly adequate way of creating copies of an object. And here we are looking at a closer with some demoing of some of these various different classes. Of course, we have our date class here, and one of the things to keep in mind is we of course have our copy constructor here because we're passing in date, a date, and so that allows it to pass in real easy. And you notice in here it says month equals date, a date.month, a date.year, a day.day, a.year. But when we go look at person, if you recall with the person class, when we try to use that same copy constructor here, remember we cannot simply just say that, for example, born is equal to born. And why is that? Well, part of the reason that we didn't quite touch on is also because date is a class used by person. If we had something where we reference a person object inside of this date copying, then we would have to do the same thing. So just kind of keep in mind, if you need to reference another class, you're going to make sure you create a new instance of that class. Otherwise, you're going to have those issues that we have just discussed. Now, if we go ahead and look at our person demo here, one of the things that you'll notice in here is that we have a couple persons being created, and then we are printing them out, and then we are creating a copy right here. All right, and then we're going to try and compare those. So let's just go ahead and give that a quick run. And you can see that when we compare them, you'll see that the answer we get back is that they are distinct copies and they have the same data. And what does that mean? They have distinct copies. Remember, if they have distinct copies, that means that they are not occupying the same place in memory. And when we're saying that they're equals, all right, that means that they are testing the actual values of those objects. So this allows us to know with the equals knows that, hey, are these occupying the same reference memory? No, they're not. And with the dot equals, do they have the same value? Yes, they do. So again, a quick comparison for you just to see how that code actually works.